Okay, so here we've got 6 different molecules drawn, and what they would like us to do is draw the molecule identified by each of the observations that are written down. So what I want you to do is have, as I go through, stop the video, see if you can draw the appropriate molecule to the right of the observation that comes up. So here's our first observation. If we mix bromine water, the solution with the sample, one of those 6 samples, the solution changes from orange to colorless. If we heat the same sample with acidified dichromate, the solution, it causes the solution to change from orange to green. So here, just pause the video, read this, and see if you can determine what molecule you think it is based on these 2 reactions. Okay, so the first one, the bromine water, we would recognize as a test for a carbon-carbon double bond or a carbon-carbon triple bond. There are 2 molecules that have a carbon-carbon double bond. They are 4 and 5. So we're assuming that the answer must either be 4 or 5. And then we look at the next test that they did. They heated it with acidified dichromate, which is an oxidation reaction, and it changed from orange to green. So it was oxidized. Now, the things that can be oxidized are primary and secondary alcohols and aldehydes. Number 4 is one of our first options, but it has a carboxylic acid functional group. It is not going to be oxidized. Number 5 has an aldehyde functional group, and it is going to be oxidized. So number 5 both has the double bond that will cause the observed reaction with bromine water, and the aldehyde functional group that will cause the observed reaction with acidified dichromate. And this is the molecule here. Okay, let's have a look at the second one. Don't forget to pause after you're shown it and see if you can write down what the right answer is. So mixing a potassium permanganate solution, Mn4- with the purple, this is a purple solution, and it produces a brown solid. When heating with Pheline solution, the blue color persists. Okay, so it tells us a couple of things here. The first thing, potassium permanganate solution, if we add that to a double bond, it will produce a diol. And the purple color, the purple permanganate, will turn into brown manganese dioxide. Now, so this must have a double bond. That's what the first observation is saying. And the second one here says Pheline solution stays blue. Now, Pheline solution is a blue copper solution that when we add it to an aldehyde, it will turn orange. So it oxidizes an aldehyde to carboxylic acid, but it won't react with anything else. Because it stays blue, it's telling us that there is not an aldehyde functional group, and the first one is telling us it is a double bond. So again, we have 4 and 5. There must be a double bond present, but it doesn't have an aldehyde functional group. So the answer to this one must be molecule 4. There we go. And the last one, again, once we've read it out, pause it and see if you can work out what the unknown molecule is. So if we heat with Tollens solution, Tollens reagent, it produces a silver mirror. Now, heating with Tollens reagent producing a silver mirror means there is an aldehyde present. Mixing with bromine water stays orange. When you mix it with bromine water and the color doesn't change, it means in a short time, it means that there is not a double bond or a triple bond present. So it can't be 4 or 5, it can be 1, 2, 3, or 6. It does produce a silver mirror, so it must have the aldehyde functional group because Tollens reagent only reacts with aldehydes. That leaves us with molecule 2. It is an aldehyde that doesn't have a double bond. And that is our final unknown molecule. Okay, let's look at some more examples of these. Okay, so here we're given 5 different molecules with the associated functional groups, and we need to write the correct number associated with the observations that are recorded on the left-hand side here. We have some chemical tests and some physical tests. Now, they're all soluble in water, and usually molecules that have amine, aldehyde, carboxylic acid, alcohol, or ketone functional groups are soluble in water. So we can't use the physical properties really to separate out any of these. But the first thing we're told for our first sample, the unknown, is that bubbles form on the addition of sodium carbonate. So when we add a carbonate to an acid, we produce carbon dioxide. Those are the bubbles we observe. And sodium carbonate is a definitive test for a carboxylic acid. So we must find the one up here that is the carboxylic acid. That is number 4. So we're pretty confident it's number 4. Let's just check. So if a purple solution to brown solid, so the purple permanganate solution turns into a brown solid when we add potassium permanganate, it goes from purple to brown. Okay, so that confirms, because it has a double bond as well, we would observe that reaction when we add potassium permanganate. So the first unknown compound is number 4. So the second one says, the two observations, is damp red litmus paper turns blue. Okay, so that means that there must be a base, and the functional group that is a base is an amine, and we can see that it is molecule 5 has an amine. We have another observation here. Let's see if this confirms it. It says heating with Tollens solution produces a silver mirror. Okay, so we remember that Tollens reagent or Tollens solution will only react with an aldehyde. So does 5 also have an aldehyde? Yes, it does. So this answer is going to be number 5. Okay, so the last one is red litmus paper stays red. Now that there is, it doesn't mean that it is an acid. It could be neutral. It's just saying it isn't a base. So it isn't an amine. It can't be 5. When we heat it with Tollens solution, it does not produce a silver mirror. That means it does not have an aldehyde functional group. So it can't be 3 and it can't be 5. When we heat with acidified dichromate, it results in a color change from orange to green. Now, if 1, 2, and 4 we added acidified dichromate, the only one that could be oxidized is the primary alcohol. That's number 1. Number 2 is a tertiary alcohol, and it cannot be oxidized. And number 4 is a carboxylic acid, and it can't be oxidized using that. So the answer for the last unknown molecule is number 1. Hopefully that has helped you get your head around how we might use observations to identify unknown molecules. Good luck.
Hey, thanks for watching this video. Hopefully this has made you more confident with your chemistry. Don't forget to like, subscribe, or leave a comment about anything that you want to with this video or any questions you have. I'll see you later.